So like when I was telling all my friends and family, like, oh, I'm going to Jacksonville, it's going to be like 16 degrees, 20 degrees. They're like, that's cold. I'm like, Celsius. Like, I don't know what that means. So here we are. So just some standard disclosures, some consulting, some collaboration, and some funding that I get. Importantly, though, nothing is influencing today's talk. Everything that I'll be presenting today is of my own opinion, does not reflect those of my employers, and is from my own personal experiences as well. So I wanted to start with a little bit of a poll, mostly for me to try and get a better idea of all of you, and maybe for a little bit of yourselves to learn a little bit more about each other and your colleagues. So I'm curious to know how many people in this room may have encountered some form of gamification during their formal training or education. So maybe just by show of hands. And when I ask you the question, if you put your hand up, if you could just keep it up really quickly, and we can kind of see how many people were impacted by this, whether you know it or not. So has anybody in this room ever played a game like Farmageddon or Empiric, which is like an actual game that's designed for like medical students or people that are just genuinely interested in like microbiology or things like that? So just by show of hands. I saw like 2 hands pop up. Pandemic counts, yeah, if you played Pandemic. What about Kahoot or like a Crowd Party or some kind of like trivia-based thing, specifically like for your teaching and training? Yeah? What about like Microbial Pursuit, which is like a daily trivia thing that you can use on your phone? They ask like a new question each day and okay. What about medical simulations or training simulations? We're starting to get into a little bit more formal practice. All right, and this is, what about eye clickers during college? Did you ever go to course and then they make you take like the clicker remote for multiple choice questions? So I'm seeing a lot of people raise their hands. So probably about half the room have at least been exposed to this one form or another. Well, these are all examples of serious games or gamification of medical education. So here are the learning objectives for today. By the end of my session, my hope is that you'll all be able to recognize the pros and cons of medical education games, decide whether or not they're appropriate for different learners, as well as understand how to design or evaluate these games yourself. So before we even say the word game, we know something important, and that is generally passive learning and passive lectures don't really work that well. High engagement and active learning, consistently shows better outcomes. When a learner is able to make decisions, struggle a little bit, and then get immediate feedback, we often see that retention improves. Games are really just a form of structured learning with extra motivation that's layered on top. So the question isn't, do games work? Rather, it should be, why might games work better than traditional education or what we're traditionally doing in an educational setting? I understand the irony of this, talking about games while I'm lecturing at you. So if you can kind of take that with a grain of salt, there are some more interactive things that we're going to be talking about later today. So game-based learning isn't just about replacing education with entertainment. It's about using challenge, feedback, repetition, stakes, competition, a whole bunch of other variables and tools to supplement education and supplement teaching. There are things that games do naturally that traditional teaching often doesn't do. A study was published by Pettit and colleagues in the BMC Medical Education Journal, where they looked at the implementation of a few different microbiology-themed games as part of a formal education curriculum in an undergraduate program. So what we know is that active learning yields positive outcomes. So they submitted a survey to the students that demonstrated overall positive results about engagement. A lot of the students felt that they were able to focus on the activity more, that they enjoyed the friendly competition. They enjoyed it being more interactive. They felt that they were really being able to explore all aspects and facets of learning beyond just kind of sitting, listening, and then trying to absorb. Additionally, students also felt that game-based learning resulted not just in higher engagement, but also deeper learning. So they felt that the variety of games that they played helped them stay focused. They were actually able, some of them even reported making connections and learning to love microbiology, which I think is a big thing too, because passion isn't something that is inherent with everyone that has to take a microbiology course. Sometimes we just have to take the course because it's a requirement. But if you start to enjoy the subject matter, I think we can all relate to the fact that we tend to be more engaged and more intentional when we do things and when we read about it. I like this slide because it reminds us that games aren't just trivia and that we can have a broad genre of games, anywhere from adaptation to adventure, training simulations, and even something as silly as an escape room can really be utilized in education and healthcare settings. This means that we could potentially match the format of the game to the skill that we're trying to teach. So an example of that is if we're trying to teach memorization or core concepts, we might want to use a quiz or a trivia-based game. If we're trying to teach clinical reasoning, we might use a simulation or a virtual patient. If we're trying to teach teamwork and communication, we might use a multiplayer board game, or we might use an escape room. So one size definitely does not fit all when we use the term medical education games. Mechanically, most educational games use competition, repetition, and immediate feedback and progression. So game-based learning strategies can really fall under two broad categories. The first is serious games. So serious games, whether they be on a computer, on your phone, on an app, a physical game, is to provide a challenging goal with some kind of scoring mechanism to teach something, teach a skill, teach some knowledge or an attitude. This is a tool to create interactive learning. Where the flip side of that is going to be gamification, where it's a real life scenario or a real life situation where we're applying game theory to it. Let me give an example outside of like healthcare and medical education. You can imagine games like your Wii Fit, the boxing, or like a Zumba game that you plug into like your Wii or Switch or something like that. That'd be an example of a serious game that's meant to promote fitness, movement, activity. It's a game that supplements you and has the intention of having you move around. Something like gamification would be like a step counter, maybe something on a watch that reminds you to stand up every hour or so. That is something that we do in real life, where we take game knowledge or game theory. We want to hit 8,000 steps a day. We want to hit 10,000 steps a day. That would be an example of gamification. We're going to go over a few published studies today, but there's a lot of anecdotal support and benefits when we talk about game-based learning in healthcare. So most learners consistently report that they're more engaged, they're more motivated, and that they actually enjoy learning. And while that last point sounds obvious, I think it's probably the most important. I mean, like, personally, myself, if you have residents who are voluntarily showing up early to a lecture because they know that they're going to be doing a game review that day, I think that's a huge win in your books, because now you have learners that are already excited to be there, and just trying to keep their attention is half the battle, as I see kind of glazed eyes, and I'm trying to keep all of your attention with this talk right now. So now comes the part where we learn to temper our expectations a little bit about medical education games. And bonus points if anyone gets the movie reference that this GIF is from. It's from the 90s. It was a great movie. But current literature on game-based learning in medical education demonstrates strong evidence for both enjoyment and engagement. However, there tends to be mixed evidence for long-term retention and knowledge gains. So games aren't magic, they're tools. And like any tool, design matters, and we should know how to properly evaluate what a good tool is. So these next few slides are going to talk about how we can engage and how we can evaluate different tools for teaching, not just games, but beyond games as well. So introducing the Kirkpatrick model. So has anybody heard of this theory before, this model, Kirkpatrick model? A lot of head shakes. I saw one person, one or two people. This is new to me too. I actually only really discovered this Kirkpatrick model when I started really getting serious about kind of novel or interesting ways to keep my residents' attention while I was teaching and lecturing. But the Kirkpatrick model is a model and framework that's designed to evaluate the effectiveness of different training and educational programs. The core idea is that any educational program should not only keep the learner or the student engaged, but they should actually learn something. It should change the behavior or their performance, and it should lead to meaningful outcomes in the work that they do with the knowledge that they're receiving in that topic. The model assesses learning interventions across 4 different levels and asks 4 different questions. The first question is, did they like it? Did they have fun? Were they engaged? Did they learn something from it? Did their behavior change? And then lastly, did we see any improved outcomes from our education program? So let's delve into this a little bit deeper and talk about each level. The first level is going to be level 1, which is reaction. And this is going to be focusing on the learner's experience and their engagement. And the primary influences at this level are going to be motivation, enjoyment, as well as perceived relevance of that game to what the learner is supposed to be doing or taking into that topic. So a couple examples of these can be like those quizzes, those trivia, using flashcards or matching games. Even escape rooms have some merit here as far as measuring reaction. This is probably the level where gamification shows its strongest and most consistent effect. And that's because it's really easy to collect data at this level and identify learner buy-in. You simply just ask a survey. Did you guys have fun during this lecture? Was it entertaining to you? But the limitations for this is that engagement does not measure actual learning. Positive reactions do not guarantee effectiveness of that program. So we have to be very mindful of the fact that this is still very superficial. So if we take an example of that serious game like Farmageddon or Empiric, we could give these out to our learners, let's say our target audience that are going to be like first-year residents or something like that. And then we can evaluate them by saying, like, did you guys have fun playing this game? Was it enjoyable? Was it related to what you're going to be doing in practice? The second level is, are they actually taking anything from this? Did they learn anything? So this is going to be focusing on knowledge and skills. The primary influence for this is going to be active learning, practice, feedback, and retention. Some examples of this can be a little bit more applied, so virtual simulations, gamified quizzes with spaced repetition. That's the important thing too, is because we want to be able to get the feedback and have it routinely drilled in. They say that repetition is like the road to learning, just kind of being exposed to it over and over and over again. And we know that well-designed medical education games outperform passive methods for teaching and retention in clinical reasoning. So that's why it's important to get that feedback immediately. Going back with the same example, we can then take those same first-year residents or trainees and put them through something a little bit more rigorous, like a skills checklist. Maybe we give them a pre and a post test after implementation of that game. And maybe to give some post-traumatic memories, like we can do an OSCE or something like that. For those of you that haven't gone through formal training, an OSCE is an objective structured clinical examination. Most of the time they have hired actors, something along those lines. You'll be given a checklist and then you have to walk in and simulate the full scenario with that patient. It can be very tough for medical learners. Okay, level 3, behavior. So now that we've established that they enjoyed the training and teaching, they actually learned something from it, are they applying what they learned into what they currently do? So the influences for this are going to be decision-making, teamwork, communication. Are they adhering to procedures? Again, virtual simulations and team-based games are going to be kind of the big ones that you're going to look at for evaluating this in terms of a game or format. The thing that's tough about this is that it's hard to see whether or not this is directly attributed to the game, because we can really only evaluate behavior from a medical education game is if it's supported by their clinical, like the clinical reinforcement and system alignment. And what I mean by that is, let's say you learn something from a game in terms of how you should practice, but when you move to your institution, the procedure tells you don't practice that way. So it's kind of conflicting in a sense that you're not actually able to measure that outcome because the procedures say otherwise. So again, we can do this by workplace observation of those trainees while they're doing their rounds. We can have direct reports, evaluations, as well as competencies to evaluate level 3 behavior. And level 4, results. So this is going to be focused not only on the learner, but beyond who the learner impacts. So this is going to be patient, organizational, system level implications. Primary influences are going to be safety, quality, and efficiency. Some examples of things that you can try and evaluate from an outcomes perspective could be reduction in HAIs or healthcare-associated infections, improved stewardship, whether that be antimicrobial or diagnostic, fewer diagnostic errors. This is going to be the weakest correlation because it's going to be hard to attribute, oh yeah, our hospital decreased our CLABSIs by 5% and it's thanks to this card game. Maybe not. So it is it is a single component that's hard to evaluate and really hard to attribute to. But again, really what we can do is use patient outcomes metrics and have a proper longitudinal study to try and evaluate this, something that really hasn't been done appropriately since the introduction of medical education games. So with all this in mind, when some Joe Schmo from Indiana comes and tells you that games improve outcomes, we should probably be a little bit more skeptical and look at it with a little bit of a lens saying, okay, they improve outcomes, but what type of outcomes? To what level? That's what I'm trying to get across by using the Kirkpatrick model to evaluate games and educational systems. So not all games are created equal. And this is really going to be kind of the key thesis for this whole talk. Some games are incredible learning tools. Some games are just flashy trivia with points. Design is everything. And importantly, complexity and difficulty play a big role in the effectiveness of a game too. You could have a very simple game like Candyland, which my daughter enjoys playing, even though there's no real way. Yeah, there's no point in Candyland. It's crazy. It drives me mental. To something a little bit more complex and layered, like Settlers of Catan, which I'm sure many of you have played and fought with friends and families for monopolizing all the sheep. And then something even more complex, like this game called Twilight Imperium. And Alejandro is rubbing his face, which I've heard, a game that can be quite complex, maybe a little bit more tricky than Candyland, so to speak. So difficulty is a big component of evaluating a game as well. So this will probably be the most practical slide today. And it's that when we need to evaluate or design a game, there are a few things that we should ask ourselves. And that first question is the game appropriate for the learner level? And the first thing you need to ask is, like, who am I teaching? What level of education does this make sense that I should be evaluating kindergartners on mitosis? Probably not. So try to make 2 and 2 add up. You can look at the learning objectives. What is the point of this game? Are we trying to recall knowledge? Are we trying to make the learners think? Are we trying to make them follow a procedure or communicate? And then we can look at the context of use for that game. Is this a game that the learner can just do on their own time, anytime they want, like on their phone? Is this something that can only be done with access to internet? Do you need at least 3 other people to do this? That's how we assess appropriateness of that game. We want to look at cognitive load balance. Is the game, what is the complexity of the game? Is it hard to learn? If residents need to spend 15 minutes to learn how to play a game, you've already failed, because the difficult part of the game should be the knowledge, not the instructions for the game. You can ask yourself, is there a way to scale difficulty and gradually increase difficulty? If the learner makes a mistake or loses in the game, do they still benefit? Do they learn something from that? And then lastly, the educational objectives should be clear and concise. They should know why they're playing this game. What am I trying to learn from this? That should be very direct. So we're going to go over some examples, and I think this is the fun part of the talk. So we're going to play a few different games together, and I tried to scale it such that we can do it in a large group of people or a large room. But your exercise is going to be, as an evaluator, to think about these different games based on what I told you about the Kirkpatrick model, based on different variables that we talked about. We're going to imagine that your target learners are a bunch of first-year pathology residents. So as we go through some of these games, the things you want to start thinking about, like, is this appropriate for first-year pathology residents? Is this difficult? Can we scale this? Is it easy for them to access? And what is the point of this game? Are they trying to learn? So this first game, it's called Bacteria in the Cafeteria. So this is through the American Museum of Natural History. And you can play a game to solve a microbe riddle. So if you find how to play, find and click a star, read the fact, figure it out, and if the microbe describes it can help people or hurt them, you pick. Seems easy enough. We learned the rules in about 13 seconds. Let's play. Okay. So we see some stars. Let's click on this first one. Raw meat can be loaded with bacteria like salmonella that can make you sick. Do these bacteria help people? I would hope that you all get this question right. So no, they don't. Good thing this burger is being cooked. And look, we got our letter here. That's great. Don't worry, I'm not going to make us go through all the letters, but let's do one more that maybe we can try and see if we can get intentionally wrong here. How about this plant one? Bacteria in the soil break down dead twigs and leaves and help this flower bloom. Do these bacteria help people? This is kind of subjective. The higher knowledge level, you could probably argue it both ways. So they're probably going for yes. So let's just say no, just to see what happens. Wrong. These microbes recycle everything that dies and makes the soil and replenish nutrients so that new plants can grow. So we're already seeing here that you kind of end up at the same result regardless of what you answer. So it's just kind of forcing you to click through buttons. You are forced to think about it a little bit and try to rationalize your thought. But it looks like that even if you get it wrong, you still learn something and you still get an objective. Or you still accomplish the objective and get a letter. And it still tells you which ones you got right, which ones you got wrong. So that's the first game. And we're not going to go beyond that because I think I was just trying to exaggerate a little bit there. So now we're evaluating this game. Let's think about the appropriateness for this. Do we think that this is appropriate for PGY1 pathology? No, overwhelmingly, heck no. Okay. Learning structure. What are we trying to learn here? I think a lot of it has to do with knowledge recall and clinical reasoning. They kind of ask an arbitrary question which may or may not be related to what they're going to be doing in practice, and then they have to make their best guess. So, meh. Game context. It's online, it's a web-based. So the nice thing about this, at least, is that they can do it at any point, at any time, on their phone, on the computer. They don't need other people to do it. So I will say, for accessibility, it is very accessible, which is good. Cognitive load. We learned the rule in, what did I say, 13 seconds or something like that? Pretty easy. Can we scale the difficulty? Not really. Not much we can do with that. And then do we learn from failures or mistakes? Sorta. But overall, good game, maybe for some kindergarten kids and maybe some kids in elementary, but not entirely appropriate for our PGY1 residents. Let's move on. Microbial pursuit. If you guys scan the QR code that's on the TV, this is a daily trivia quiz that they publish a new question every day that has to do with microbiology. And I actually didn't do it today. I used to do this a lot when I was a trainee as well as part of my self-teaching. And the idea is that you get 4 hints to try and guess the pathogen or the organism or drug or target. Oh, I'm so sorry. Okay. Hold on. I think there's one on here. Let's just do it together then. How about we do that? Okay. So you can just type in microbial pursuit. Like they do a new question every day, which is kind of cool. So let's see. Get ready to play. Guess the name. 4 total clues. 1 correct answer. The less clues you get, the more points you get. So clue 1, I bind with ergosterol, which is a component of fungal cell membranes, and this leads to subsequent fungal death. I was isolated from Streptomyces nodosus in 1955 from the riverbed of Orinoco, Venezuela. Anybody have a guess? We're looking at antifungals here. We can keep going. So if we don't know, we go to the next clue. I am a polyene. I have activity against a variety of fungi, including yeasts, mold, and dimorphic fungi. However, Candida lusitiniae is intrinsically resistant to me. I also can be used in the treatment for leishmaniasis and mucormycosis. If you know it, yeah. Some people would say it is terrible. Yes. So let's see. Answer for 75 points. Info comes up. Correct. So that's the daily puzzle. You can go back to the previous games. They have all the games that they started for 2026. It's a cool little fun trivia thing that you can do for funsies. Microbial pursuit. I actually really enjoyed doing it. Just, again, I feel like I'm with my people here. I'm a little nerdy. I like microbe trivia stuff. So I think this is something that you guys can reasonably do and enjoy doing it. But if we're evaluating it from a medical education standpoint, is this appropriate for the learner level? I'm seeing some nods. I think this is a little bit more on par in what we would be able to expect them to know. I think the way that it's presented is probably a little less practical, as it's not really a clinical situation or not necessarily drug interaction, but kind of random factish. So like, 1955 discovery date. That's probably not as helpful for your practice. Learning structure, it's a knowledge recall, straight up. There's no clinical reasoning to this unless the quiz gives you a prompt. Game context, again, self-study, portable, easy, available. Cognitive load, it's tricky, easy to learn, but it can be tricky. And if you try to guess it with less clues, that's kind of one way of scaling the difficulty and keeping track of points. And the educational objectives are clear. You're trying to just kind of recall random clinical microbiology facts. So a little bit better than bacteria in the cafeteria, right? Yeah? Okay. Let's move into something a little bit more targeted. I really hope this video works. Do we know if there's sound? We're about to find out.
without knowing the exact bacteria being treated. They are instead selected based on common bacterial causes of a set of symptoms. This is empiric therapy. To do this well requires understanding which bacteria cause certain infections and which bacteria each antibiotic treats, with spectrum of activity. Empiric is a 15-minute game used for medical and pharmacy learners in the busy clinical setting. Empiric reinforces antibiotic basics with color-coded mechanisms of action and iconography for important bacteria like MRSA, MRSA. Players manage a hand of antibiotics, matching antibiotics or observation without antibiotics to clinical cases. One antibiotic might work for many cases, but will score the most points when used for the most difficult infection it can treat. This rewards antibiotic selection to minimize the development of antibiotic resistance. Content is based on society guidelines and is peer-reviewed by physicians, ID specialists, and ID pharmacists. Empiric is being used around the US and internationally, distributed both as a print-on-demand game and a free-to-download print-and-play with pediatric, adult, emergency medicine, and veterinary versions.
Has anyone played Empiric before? Really fun. And I think the key important thing there is it's free. You can actually go to Empiric Antibiotics, and if you type it in Google, all you have to do is put in an email, which gives you access to the Google Drive account. And you can actually print off all the cards yourself, and then they're double-sided. They'll be cut really nicely, and you can make your own little flashcard game with Empiric Antibiotics. We keep a deck of these cards in the fellows office at IU, as well as like our rounding room when the ID and ID Farm trainees come through in case they want to just kind of hang out and play some quick games. But I do have, let's try and work through this together, because I wasn't just going to show you a video and hype this up. Let's see what we can actually do here. So I decided that maybe we can work together as a team. So the rules, about 1 minute and 30 seconds, we kind of had the gist of it. We're trying to diagnose the bug with the appropriate drug. So it looks like we have 3 different drugs here. We have doxycycline, penicillin, metronidazole. Let's work through each of these cases together, and then maybe we can try and vote or come to a conclusion on which drug we should use. So the first case is cyclospora. It can also be no drug, right? Because we don't want to just aimlessly treat things. Stewardship for a reason. So cyclospora is a 44-year-old woman with 2 weeks of watery diarrhea and weight loss after international travel. Serial stool microscopic examination revealed cyclospora oocyst. So are there any drugs here that we might try and treat our cyclospora with? I'm seeing a few answers already based on head nods or head shakes. Yeah. With the 3 drugs that we have here: doxycycline, penicillin, metronidazole. Sorry, it's a little bit small. I apologize if you guys can't read the screen. I've heard 4 people just kind of like mutter no. So let's see what the response is. Bactrim. So trimethoprim sulfamethoxazole is the treatment of choice. I can't even read that, so I'm not going to try to read it to you guys. But we would flip the card over, essentially, and then we would see whether or not our drug of choice was appropriate for therapy or not. In this case, if we tried to use, say, doxycycline, we would lose the drug, we would lose a point. That's kind of the game mechanic for that skill. Let's turn that back over. Anaplasmosis, 60-year-old with acute onset of fever, headaches, and myalgia 5 days after hiking in northeastern United States. Thrombocytopenia, leukopenia, and elevated liver enzymes were noted. So they were diagnosed with anaplasmosis, probably from a blood smear or PCR maybe. Can we treat with any of these 3 drugs, doxy, penicillin, or metronidazole? Hearing a few answers. We're hearing doxy. We're happy with doxy. Okay, so we'll click on doxy. We'll click that. Doxycycline. So we would be able to remove this card from our category of diseases that we treated. How about primary syphilis? Without reading the case, is there anything here we can treat syphilis with? Not love. We treat it with penicillin. So penicillin G is how we treat syphilis. What about bacterial vaginosis? So a 34-year-old presents with 3 days of increased foul-smelling vaginal discharge, notes a fishy odor. Microscopy of the discharge shows these characteristic clue cells. Heard a couple people tell the answer, so we're hearing metronidazole. So we'll use metronidazole. Metronidazole, clindamycin, yes. And then this last one, fight bite. 21-year-old patient presents with spreading redness and purulent discharge at the site of a closed fist injury during a fight. So this is now assuming we have a diagnosis of what we think the fight bite is, and now trying to select, based on that assumption, what drug do we use? So it's kind of a two-tiered question. And we're starting to think of our fight bite often refers to why it's called a fight bite. For those of you that aren't aware, when you kind of punch somebody in the face, maybe like you hit their tooth, exactly, yeah, and you kind of get the fight bite, so to speak. So I'm hearing some mixed replies from the audience, but this is typically going to be Eikenella is what is the causative agent of fight bite. And in this case, we're going to be using amoxiclav, which would be none of our drugs on target. So this is pretty much a quick sum up of how you play empiric. And you can just, they say 2 to 4 players because you're trying to compete with the person ahead of you to try and diagnose and treat more appropriate infections. But you can do this by yourself as review as well. And it's actually great practice. So kind of going through our lens, let's see, there we go. Appropriateness for the learner level. Highly appropriate, yes, very appropriate. Learning structure. I think it does a good job of everything here, to be perfectly honest. We need to be able to recall our knowledge. We need to do clinical reasoning with what we're seeing. We need to follow procedure as well. As you can imagine that if you have a patient that might be intubated, you probably wouldn't want to give them an oral drug. Teamwork, you can turn this into a team game. Game context. It could be self-study, it could be small groups. It's fairly portable. Cognitive load, difficulty. You know, the video was about 2 minutes, and then you kind of get the hang of it after the first round of games. So fairly quick to pick up, which is nice. And we can scale the difficulty. We do learn from our mistakes. I think this is a very good, serious game that we could use for medical education. Let's move to the next one. So this next one is going to be an excuse to play more games because that's why we're here today. I believe this one here. So we have had some people here that have already played Kahoot. For those of you that have never played before, this is a quiz game that you can join by going onto your phone. Simply go to the website, which is kahoot.it, and enter the game pin or scan this QR code. And I'm going to be very sad if there's not a lot of engagement in this because I had to subscribe to Kahoot to get more than 10 people. So I'm just saying I paid out of pocket just so you guys can play a game with us today. I don't think Francis would reimburse me for this talk. So yeah, I'm quite good at it. It looks like we got one person in. So I did put together a couple of questions that I thought would be kind of appropriate for our broad learner ranging audience here today. So what's going to happen is we're going to go through 10 questions. They're all multiple choice. They're all going to be anonymized to whatever name you decide to pick out. It's going to pop up on the screen, the question. I'll read the question out loud too. And then you can also read it on the screen if you can see that far. And then it's going to show 4 possible answers on your phone. Each possible answer is going to be associated with a color or shape. So make sure you're pushing the right color or shape to that answer. And one component about Kahoot that not a lot of people talk about is the fact that if you answer the question faster, you get more points. So when I was going through Kahoot as a trainee, my strategy was to be the first one to answer till you get maximize the amount of points. Where it backfires is if you haven't even read the second half of the question and you immediately discover that you should have read the full question before answering that question. So that's kind of the game component behind it, is you want to try and answer accurately, but if you answer quickly, you also get additional scoring points for that. So we have 12 people. Kahoot.it, and then it should ask you if there's a game pin to join. I see like 2 or 3 people still trying to join. I will wait just a tiny bit longer. I will try and join right now really quickly to see if, yeah. Yeah. So you enter a nickname. There you go. Oh, fitting. They made the Canadian a moose. I love that. Okay, 14 people. I think we're good to go. Are we ready? Oh, sorry. Are we in? You can also play with a friend if you don't have your phone or if you don't want to try and get it together. Two minds might be better than one, but it might also be slower than one. In terms of speed, not in terms of actual, being quick with it. Okay, let's get into it. 17. All right, here we go. You guys see your name? You guys know who you are? We are going to get started with Kahoot. Let's go. Yeah, see, plus I paid for it. I'm just saying. Thank you. Which of the following gram-positive bacteria is resistant to novobiocin? You have 20 seconds. Staph aureus, Staph epidermidis, Staph hominis, Staph saprophyticus. And they add music and it speeds up, so it makes you really antsy and anxious. Yeah, it's great. Saprophyticus. Okay, so we're gonna go next. And we have a leaderboard. Oh, so now we're competing with each other. This is the element of where now you're trying to see who's who here. Okay. All right, question number 2. Let's go. Which of the following malaria parasites produce hypnozoites, liver stage parasites? Is it falciparum, malariae, ovale, knowlesi? The answer to the last question, by the way, for those of you that didn't know, was saprophyticus. So it should have been D, or the green box. The answer was ovale. Yeah. So ovale, and does anyone know what the other one was? The other malaria parasite that has hypnozoites is? Vivax, yes. Vivax and ovale. Okay, we have some moves on the leaderboard. How bold of those that use their real name on the leaderboard. All right, question number 3. Which of the following would not be an antibiotic of choice for the treatment of Enterococcus gallinaria? Ampicillin, vancomycin, linezolid, daptomycin. So this question is looking at intrinsic resistance in Enterococcus. Vancomycin is the correct answer. So we're looking in this case, I believe it's the Van E gene or Van C gene, sorry, thank you. Van C gene and Gallinaria, which it has, so it has intrinsic resistance to vancomycin. Okay. How's the leaderboard doing? Vets. Oh boy, with the speed. Okay. All right. Move on to question number 4. When staining for mycobacteria, or AFB, the primary stain used in the acid-fast staining process is acid fuchsin, carbol fuchsin, crystal violet, methylene blue. Carbol fuchsin. Okay. Oh, Yvette has the highest answer streak of 4. It's just rubbing it in here at this point, isn't it? Number 5. Which of the following mycobacteria is known to cross-react or produce a false positive result with an IGRA test? Interferon gamma release assay, IGRA. So we have Macavium, Xenopi, Haemophilum, Sulgi. That's actually a good strategy. Just pick one if you're not sure. That's a good strategy. Is it a good learning tool? I don't know. We'll evaluate that after. Sulgi. Now, this is going to sound really random because this is a question I actually ask our residents. So there are 3 mycobacteria that do tend to cross-react with IGRAs, and that's going to be Sulgi, Marinum, and I believe Kansasii, so SMK. And my really, really dumb memory mechanism for remember that is remembering the initial, so SMK. And there's a Red Hot Chili Peppers song called Suck My Kiss. So SMK, Igara, Red Hot Chili Peppers. It makes sense in here. The rest of you think I'm crazy, but that's right. So whatever works for you, that's how you memorize it. All right, let's look at our leaderboard. Oh, no movement. Okay. Which of the following organisms would you not see produce hyphae in tissue? Rhizomucor, histoplasma, Candida albicans, or Cleidophilophoria bantiana. These are all fungi. Where are our mycologists at? Histoplasma. So it is a dimorphic mold. So the memory mechanism for that is mold in the cold, yeast in the beast. Okay. Movement down below, but Yvette and Orlando holding strong. Ooh, it's really close after that. All right. Sporothrix brasiliensis, which is closely related to Sporothrix schenkii, is commonly transmitted by which of the following methods? Cat bites or scratches, traumatic inoculation, ingestion, or inhalation? Sporothrix brasiliensis. Cat bites and scratches, believe it or not. There's actually an island off the coast of Brazil that's known as like the Sporothrix brasiliensis island that has like tons of feral cats and is just rip-roaring with Sporothrix brasiliensis. So Sporothrix schenkii, which we're more probably familiar with, is the one that's transmitted by traumatic inoculation. So that's kind of known as like the rose gardener's disease, or you prick yourself with the thorn of a rose, and that's how it gets transmitted. Look at our board. Mold. Representing. That was fitting. How do humans get infected with Dibothrocephalus latus, formerly D. latum? Fecal oral consumption of eggs, fecal oral consumption of larvae, consumption of eggs from undercooked fish, consumption of larvae from undercooked fish. This is a mean question, and it's something I would ask my fellows. No. That's why. Speed. Sometimes speed, sometimes accuracy. So it's larvae. It's not the eggs. With D. latum, like it actually has to go into the intermediary host, which is usually like the smaller fish. And then it matures into the larvae from there. And then we eat the infected broadfish, or like the larger fish that has the like the proglottids in the larvae form of D. latum. Mold. Mold. Newman. All right. EBV is associated with a wide variety of tumors. Which of the following is EBV not commonly associated with? Burkitt lymphoma, nasopharyngeal carcinoma, Hodgkin's disease, oral squamous cell carcinoma. Virology question. Oral squamous cell carcinoma. Does anybody know what oral Nice. Okay. Leaderboard. Mold and Yvette. Okay. All right, I think we're moving to the last question. Which of the following HPV genotypes is not considered high risk for the development of cancer? 11, 16, 18, 33. Which is not considered high risk? $11. And I believe the tip for that remembering is like 16 and 18. If you take 15 and add it to that, so that corresponds to 31 and 33 are also considered high risk, but there's a couple other ones as well, 45, a few others. Okay, let's look at our final leaderboard. Third place, we have Orlando with a frog with pancakes on his head. Yvette at number 2, and number 1, everyone's favorite, mold. All right. Great job, everybody. Round of applause. All right, so that was game number 4. Oops. Let's go back. I'm going to close it so the music stops playing. How about that? Okay. So, appropriate for the learner. I think this question can be tangible because I made the question. So I made it appropriate for what I would consider appropriate for PGY1s. Learning structure. This is purely knowledge recall, maybe some clinical reasoning based on how the questions are phrased. Teamwork, no, y'all were up trying to get in each other's grills about this. It was crazy. Game context. I think you need a small group for this. I don't think this is something that you can do that's on your own time, even though it's fairly mobile and accessible. Cognitive load, pretty easy to learn the rules, maybe not as easy to set up. So, we're teetering on the side of difficulty for learning rules. And then can we scale the difficulty there? We can by base of questions. Do we learn from failures or mistakes? You hear the right answer, but if I didn't talk over some of the explanations for those answers, would you guys have learned anything from that? Probably not. So I think part of that falls on the lecturer as well as the person who's facilitating the game, as opposed to the game itself. So if we're asking, does the game itself teach you from your mistakes? I would actually say no, it doesn't. So still, overall, decent game, highly engaging. We're going to answer these questions at the end, and you're all going to be quizzed on it. Okay. Last game that we're going to go over today. This one is a game that I actually discovered towards the end of last year, and it's called Microbe Invader. It sounds a little ridiculous, and it is. So let's go through together. Welcome to Happy Hospital. It's time to create your hospital badge. We are scrubby student. Sure. Yeah, that looks like me. Oh God, how do we turn that off? Okay, so we're going to ditch the lecture for sake of time. Do we agree with that? Okay. So it is a full-on web-based game. I am moving on the keyboard here. I had to learn how to play this game really quickly before we came here again, so I can run it through with you guys. But it just goes to show you like some of kind of the ingenuity and the thought that people put in. So it looks like we are an infectious disease resident. We're rounding at the hospital. So I think we can call this kind of like a platform or a simulation-based game. There's different floors on the hospitals. There's a pediatric wing there. What happens upstairs? Is that upstairs or downstairs? I don't even know. Sure, 3rd floor. Surgery, let's go to surgery. Can we interact with these people? This guy looks angry. Let's talk to him. Bowel obstruction. Or ileus. All right, that wasn't helpful. Let's see if we can talk to a patient. Nobody there. Okay, nobody had surgery. Cool. Never mind. Let's go to a different floor. I swear it's worth it. Please bear with me. If I can find a patient, it's worth it. Where are all the patients? There we go. We got one. Diane Tinklerocks. Can you help me? We sure can, Diane. So here we have a 7-year-old female with a rash. It looks like really the only sample type we could. This is fitting. If this is going to be what I think it is, because we're in Florida, I'm going to like walk out the door right now. Skin swab. And then we can order some tests based on that swab. So it looks like we can do a gram stain. So we have some gram-positive cocci chains. Maybe we can order some culture. Let's do blood agar. Beta hemolytic. Okay. They even give us biochemicals. Wow. Is there anything here that you guys want to run, or do we think we have an idea of what this is? Does not make coagulase. Catalase test, what do we think this answer is going to be? Does not make catalase. I think we're pretty confident on what this is. Let's diagnose it. So it's a bacteria. I mean, there's only one strep species up here, so we're going to go with strep pyogenes or group A strep. It was successfully diagnosed, and we were able to order the appropriate tests on the first try. No unnecessary testing that was sent, so we got some diagnostic stewardship that was here. Let's treat it. Now we're in a Pokemon battle with group A strep. So we can treat it. We have penicillin, we have ceftriaxone, and we have ciprofloxacin. What do we want to throw at this bad boy? course, penicillin. Can't cross-link transpeptidases. That didn't work. Let's try ciprofloxacin. Oh, no, it did like that. So yeah. So it's super effective. Should we do it again? Used M protein. Can't cross-link peptidoglycans. So we defeated group A strep. We can see here, first time treating this pathogen. We used an effective treatment in penicillin. And like the resident you are, you got paid $24 for your time. Microbe Invader, another free game, and it's quite expansive. So you can see here we're in the PEDS unit. They have a surge unit. They have an ICU, bunch of different things. So again, there's a couple options here. Do you want to do one more, or should we carry on with the talk? Let's carry on. All right. We're going to close that just because of time. So appropriateness. Do we think this is an appropriate game based on our learner audience of PGY1 pathology residents? I think it's reasonable. I mean, our pathology residents aren't going to go around throwing penicillin at patients, but they're not going to be seeing patients in general, actually. But I think this is an appropriate knowledge level for sure. Learning structure, I think it does a really good job of kind of all of the above, maybe minus teamwork. And then in terms of context, this is something, again, that's available online. You can access it everywhere, self-study, et cetera. Difficulty learning, I mean, it took me about a minute or two to figure it out. I think that's very reasonable in terms of time. Can we scale difficulty? Probably not. The game's kind of set in stone the way it is. But do we learn from our failures and mistakes? It looks like it does show us reasoning. So if we use an improper antibiotic, you can see the little prompts on the bottom telling you like which resistance mechanisms that the bacteria has. So it continues to teach you, even though you're kind of maybe wildly throwing antibiotics as it is. And hopefully that's only in a game and not in practice. And the educational objectives are clear. So I think that's actually a pretty good game. It's not bad. More immersive, definitely, better reasoning practice, but it does require more setup for sure. Okay, so now we're going to get back and we'll wrap up with the last little bit of the talk, getting back into the lecture portion today. There's really been two major meta-analyses that have looked at the impact of games in medical education. And both of these kind of large studies use the Mirsky scores as a way to kind of compare and evaluate these many studies. So Mirsky is Medical Education Research Study Quality Instrument Scores, which takes into account your study design, the type of results and metrics that you're looking at, whether they're qualitative or quantitative results, the validity, as well as the outcomes and the impact of it. And overall, fairly moderate to okay results. Again, I think there was a vast improvement in engagement, fun, and activity and learning. But when it comes to like looking at our level 3 and our level 4 of the Kirkpatrick model and looking at like prescribing changes and like your performance and your decision making, there wasn't a lot of studies that did that. In fact, between these two meta-analyses that evaluated well over 30 different studies, there's only one study that linked serious games that was associated with patient outcomes. And even then, I actually read the study. There was a lot of different things that they did and implemented. So I thought it was a bit of a reach for them to attribute the positive patient outcomes were attributed directly to a serious game that the residents went through. So there are limitations in what's already been published so far. And the key points are that there's a lot of heterogeneity in the studies, very, very, very few long-term studies, and there's almost no behavior or outcomes data. So we're kind of being very superficial, and that's okay. There's nothing wrong with these games being superficial, because if we're still trying to teach the objective of the game, we've accomplished that objective. Now, if we're going to create a game with the objective of reducing CLABSI scores in a hospital, then our evaluation lens becomes entirely different. But we do need better study designs to really evaluate that level 3 and level 4 in the Kirkpatrick model. So what we really need next, again, is we need these studies to do a standardized evaluation. Like if they were all to follow the same approach and method, we need to actually look at reproducibility as opposed to just a one-time study. So I've been doing some interesting ways to implement educational tools with some of the residents at IU, and I've actually been doing it each year, PGY 1 through 4. So we can see pre and post-test scores, and then we can have a different cohort evaluated at the same time to see if there's any differences between this year's PGY1s versus next year's PGY1s. And then we also want to be able to compare different game types, because a lot of these studies were based around 1 or 2 games. You might want to evaluate different genres, as we talked about. There are plenty out there. So really make sure you're getting the right piece of the puzzle for the right fit. And then obviously we want to look at outcome studies. So basically, fewer "this was fun" papers to more "this was effective" papers. This is a really good slide for a lot of those issues that I raised that I kind of swiped from this article published in 2021. And it looks at a lot of the perceived barriers across the different levels. So you have the learner level, which is like the learners, which is the residents and fellows, and then you have the facilitators, which is going to be faculty and educators. So one of the perceived barriers is going to be, for an educator standpoint, is lack of familiarity on how we should be teaching adult and learning methods and what is out there, what can we use. Potential solution is to invite somebody like Joe Schmo for me to share with resources that are available to you to give you perspective and how to look at different ways you might want to teach your trainees and fellows and mentor them. And then same thing with our learners. One of the perceived barriers is poor compliance with expected responsibilities. There are ways of being able to identify content which is better suited to game-based learning that might be able to address that. It's just a really nice diagram that kind of shows that there are workarounds to this to be able to try and get long-term outcome studies done if we were to perform these. So that was a lot. And if you can walk away from anything today, aside from the fact that we got to play trivia and have a lot of fun with trivia, and you can only remember 3 things from this talk. The 3 things are that games have effectively shown increased engagement consistently, both in published studies, and I'm sure you guys had a lot of fun playing some of these games today. Engagement can improve learning superficially, kind of at that level 1 and that level 2 stage. But game design and context ultimately will determine the success of your medical education game. And there's not a lot of evidence to suggest that these games will be helpful beyond kind of that level 1, level 2. So games aren't replacement for teaching. They're tools, they're amplifiers. I would encourage you guys to supplement it into your teaching and your learning, just to kind of add in an element of structured learning, structured active learning. Some acknowledgements, Dr. Courtney Komar and Dr. Samantha Giffen. We actually gave a similar version of this talk to ASM 2 years ago. So I did use some of the content from the slides. We prepared for that. Dr. Michael Cosimini, who is the creator of empiric therapy. Dr. Scott Crabtree, who's the creator of Farmageddon. I've actually interacted with both of these individuals to try and give me tips on how I can create my own game. So they've been plenty helpful, and it's been really insightful hearing their perspective on things. My lab manager at Eskenazi for Micro, Amber, as well as the molecular manager at IU Health, Matt Sperling. They're the real bosses of the laboratory. I'm just the glorified cheerleader. And then our pathology residents for being my guinea pigs at IU, because I do throw them a lot of random teaching styles to try and see what works and what sticks. So this was an escape room that we did. I brought them all into the lecture theater, and then I locked the doors behind them and said, get out, here's 4 different puzzles you each need to complete. So we took some of them were communication based. Like one person would have to stand at the end of the room to like tell them the code to decipher, and the code was based on antimicrobial resistance mechanisms. So there are different ways to try and keep them engaged, but rather than just give them a lecture, I thought like make them work for it, make them think about it. And I just sat there and drank coffee. It was fantastic. Again, I'd like to thank Frances, who had to go pick up her daughter, and the rest of the JAM committee and all of you for listening and having me here. It's been an absolute pleasure. And if there are any questions or if there's anything you'd like to talk about, I'd be happy to stick around. Thank you so much.
That was truly so fun. Thank you for that Battle of the Brains prep. Does anybody have any questions? Do we have anything online? No?
I also totally understand if there are no questions. Kind of a strange talk to do, but I think there are some practical things that you have to do. How do you